In this video, I want to talk a little bit about the aminoacyl tRNA synthetase reaction. So aminoacyl tRNA synthetase is the enzyme that actually connects an amino acid with its corresponding or with a corresponding tRNA. So what happens here is that the amino acid, so this activates an amino acid and charges a tRNA. So a tRNA molecule, once it has an amino acid attached to it, it's considered charged. And when an amino acid is attached to a tRNA, that amino acid is considered activated. So basically we're taking a tRNA and then we're adding an amino acid to it. Now notice here, in this case, if we have an mRNA strand that is 5' to 3' and it's CUC, then it should code for leucine. So the anticodon on this tRNA base pairs here, this GAG base pairs with the mRNA. Now this tRNA should, because it has this anticodon that pairs with this codon, this tRNA should have a leucine attached to it. So we need to make sure that a leucine is indeed attached to it and nothing else is. We don't want a histidine, we don't want a glycine, we want to make sure a leucine is there. If any other amino acid is attached here other than leucine, that's incorrect, and that's a problem because this mRNA codes for leucine. If we're adding anything other than leucine, we could seriously damage the protein, right? The protein product would be incorrect. So the accuracy of translation occurs at this step. Why? Well, we need the tRNA and the amino acid to match. Otherwise, the incorrect amino acid will be incorporated into the peptide chain, and then we can get a faulty protein product. So what does the reaction actually look like? Well, we take an amino acid, right? I've highlighted the R group in a light pink color here, and that's going to be attached to a tRNA that's specific to that amino acid. Then, of course, the aminoacyl tRNA synthetase enzyme will catalyze the reaction, and it requires some energy. So ATP will be converted into AMP and a pyrophosphate, and this pyrophosphate is hydrolyzed off, and so this is the equivalent of 2 ATPs being used for this reaction. So then what we get is the amino acid becomes covalently bound to the tRNA. Now this thing is the aminoacyl tRNA. Now something to note, to pay particular attention to, is that the amino acid is attached to the CCA end over here. So it's specifically attached to the 3' OH of the CCA end, because the 3' end has the free OH group. So that's where the amino acid attaches to the tRNA. That's where this covalent bond is. So here, if we have leucine, we're going to make sure to add leucine to a tRNA that's specific to leucine to make this particular aminoacyl tRNA. So I hope you can understand that the accuracy of translation occurs at this step because we want to make sure that we add the correct amino acid to the correct tRNA so that any amino acids that we're incorporating into the peptide chain are indeed correct. So this is a very, very important reaction. Hope that video was helpful. One last thing, I am a tutor. If you live in Southern California, feel free to contact me via email at moofuniversity@gmail.com. See the description below for more details. Thank you for watching.